Hello, hi everyone. Welcome back to project management sessions for the summer. This is session 6, and we are continuing today with resource leveling and schedule compression. So today's agenda is we're going to look into the resource leveling, what it is and how can it be done. I'm going to introduce you schedule compression, and it appears in some different types. So one is fast tracking and the other one is crashing. And then I'm gonna do one hands-on activity with you, and then I'll assign you a homework to be able to apply the skills that you learned today at home. So I want you to think about just 1 minute what is resource leveling and why may you need it. So in the previous sessions we came up with our work breakdown structure and we transformed it into a PERT network diagram. And in this network diagram, we estimated the durations and we were able to find out the overall duration of the project. In this applications, we also find out the slack time 0. And when we combine the 0 slack times, we find out the critical path. Right at this moment, this critical path is, really critical. That's why we call it critical path. So you got to find out the risks, okay, and how you're using your resource. If there's peaks and valleys a lot in your resource usage, then you want to level them so you can effectively use your resources. That's basically what is resource leveling. There's different tools that you can use, but you can use as simple as an Excel spreadsheet. So think about it. In the previous example, we looked at let's say that you can complete the project in 42 hours. What were some of the questions that might arise? What is the probability of completing the project in 42 hours or less? CEO, your manager, your program manager may ask you this question. Or what is the probability of completing the project in 32 hours or less? Can you have this question asked to you? Sure, because maybe the customer is waiting your delivery, not in 42 hours, but 32 hours. So your manager wants you to state if you can complete or what kind of confidence level, what is the percentage of your confidence level that you can complete your project under 32 hours. Or if your CEO, your program manager is really knowledgeable about the project and how the projects are run, then they may ask you what is the probability of completing the project less than, more than 95% probability confidence level. Okay, so they want you to give them a time, a duration, a completion date that 95% they can be sure that the project will be completed. And you needed some statistics refresher. That's why in the previous session we used our calculators and we refreshed, get the dust out of your old knowledge about statistics. And we find out over an example what is the variance, what is the standard deviation, and we learned for a target date how to complete the z value and how to look it up the z table. Okay, and then find out the probability of success. And I'm gonna really go fast. If this slide is not making sense to you, I really encourage you to go look it up, the previous session recording, okay? Because next week we're gonna do the progress quiz 2, because this is really a natural breakpoint for a nice quiz. So there will be questions from these slides and how to calculate the variance and standard deviation and the completion success and rate in network diagram. So if this slide is not making sense to you, please go back and review the previous week. And one of the examples also I covered last week was, CEO might ask you, can you complete it earlier? whatever is your completion time, they may ask you, can you complete it earlier for whatever reason? Maybe the customer wants it earlier. Maybe there's a rush to market. From a business case perspective, you want to be the first to hit the market, and all of this. How quicker can you deliver? Can you deliver 100% on time, and all of these things? We said let's find out the CEO's question and we work on them. So let's say this is our project, okay? Starts from activity A and goes all the way to activity T, and you have the durations associated with the activities. Here you have the red arrows and nodes as critical path, okay? And by now you should know why is critical path is called critical path. How are the slack time on these red arrows? And if something happened, like if you're late or anything on one of the activities, what happens to project duration? And if you are late on one of the blue arrows, which are not on the critical path, then what happens to your duration of the project? So you know all these things. So today's topic is resource leveling. So coming from this to resource leveling, what kind of a connection we should do? Okay, so resource leveling is an attempt to eliminate the manpower peaks and valleys by smoothing out the period-to-period resource requirements. The ideal solution is to do without changing the end date. So when you're making the resource leveling, you shouldn't be making the project run more, like run longer. Okay, you shouldn't delay the overall project. So resource leveling is something that you want to do to free up some space for some of your employees, maybe some machinery, or maybe some clean labs, or some kind of classrooms, meeting rooms, right? All of these things, or trucks that you do. So you want to, level these resources so you can use them effectively. It's not, when you're doing the resource leveling, it's not desired to make the project run longer. Well, if whatever you do, the end date moves out and additional costs are incurred in the project, then that's a different story. So you need to make a new calculation. So let's say I am installing a sprinkler system in my backyard. Okay, so here's my work breakdown structure. So my main system is installing the sprinkler system. Here you see the masters, which are the acquire equipment and tools, prepare yard, dig trenches, install system, and finish job. These are the master, and these are the slave, which, for example, preparing the yard 1.4 requires you to clear the trash, the weeds, fill the holes, and rake the yard. Okay, so this is, let's say, the work breakdown structure for my sprinkler system installation project in my backyard. Let's say I'm doing this with a kid, like a teenager, and myself. Okay, so we're doing basically 2-person. But so if you look at this, what do you see? Okay, think about the different types, the various types that we studied about work breakdown structure. Which one is this one? Exactly. So this is the time sequential or time phased work breakdown structure, right? Not functional, not material. That's basically the time, because it says finish the job, and then right before that you're installing the system, you're digging trenches, preparing the yard, and first acquiring the equipment, right? So it's kind of do this, do this, do this, do this, do this thing. So work breakdown structure here is actually a time phase one. And when I draw this, I find out this per network diagram. Okay, starting from A to going to T. So here's the activity durations, and here's the critical path. Actually, this is the same slide that I showed you in a minute ago. So I just pulled out the Excel spreadsheet, and I put out nicely the activities and then the masters. Okay, you see these ones are not really the activities, they are the what we call is masters. They are kind of a title, kind of a group things together and keep them neat and tidy, so they don't have durations associated with them. So when you do this, you come up with this baseline schedule, okay, with the resources. Okay, I'm just looking from a resource perspective, from an employee perspective. So this, I'm installing my sprinkler system in my backyard with a teenager and myself, right? So I am basically using two person, let's say, okay, right? I'm not hiring any contractor, I'm not paying anybody else. So this, let me explain you what are the colors and what are these lines and what are these red lines as well. So as I mentioned before, the masters, the colored one, doesn't have any activity duration associated with them because they are just kind of an umbrella, kind of a grouping method. But here you will see that designing the yard takes 4 days. Okay, so somebody needs to do this in one day, and then this block, let's say this cube one day, and then this cube another day, and then this cube another day. And also, after I design the yard, I purchase the material. So somebody needs to go and purchase the material, and then another one. And then renting the trencher is also happening this time. But what these empty blocks means are the slack time. So I have time. I can buy the, for example, looking into purchasing the materials. I can purchase the material either in these 2 days, which is the 5th and 6th day, or 7, 8, 9, 10 until, let's say, 15, 16. Okay, I should leave. I can purchase the materials in these 2 blocks. So I have the select time of this much. Okay, and here also renting the trencher, I can do this here, 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 or here because I have slack time. Because if you look at the work breakdown structure, I don't want to open it right now, but I can dig the trenches. Well, to start digging the trencher, right, digging with the trencher, I need to acquire them. So before starting to dig with trencher, right before that, I can buy this anytime, right? So I can rent it here, 6th day, 7th, or 8th day. But I cannot rent it after 8th day because digging with trencher starts at day 9. Got the point? So that's how I come up with this echelon. So what is this red line? They are the critical path. Okay, so whatever on this one, they are critical path. Okay, so let's investigate this. Okay, so everything looks good, but does it? Okay, is there any problem? Let's look at day 5th. Is there any problem on day 5th? Think about it. So I am purchasing the material, somebody is renting the trencher, and somebody is purchasing the tools. Wait a minute, so how many person is this? 1, 2, 3. So if I collapse these blocks at the bottom, oh my god, there's 3 blocks. Let's look at here. So somebody needs to, let's say I connect the installer system to water, and somebody needs to install the timer, and somebody needs to install the pipe. Okay, that's good, but how come I do all of this in one day? Because durations are 1 day, right? And I not 2 people can do 3 things. So If you collapse these things, you see there's we need 3 people, but we don't have. So what can I do? Well, then in this case, I use the resource leveling. Okay, that's where it comes handy. So because I have select time here, okay, for example, here in this column, I have only one, rake the yard. So if I move renting the trencher to somewhere here or here, it means that this will only be 2 blocks collapsed here, and this 1 will be 2, which is good because I am already 2 people. So one of the one of them can do one job and the other one can do another in the same day. So I'm kind of leveling the peaks here, got it? And then peaks here, and I don't want to create more time to finish the project. So take a moment to think about what we covered on this slide, okay, and try to digest this, and please compare it with the PERT diagram and work breakdown structure. So if you open up baseline schedule, the PERT diagram, and then the work breakdown structure, if you open up all of them together, it will make more sense to you. Okay, but which one should I do and how can I do, right? So what if this is not good enough? What if this is not good enough? So you kind of did the resource leveling, but maybe there's select time less than what's required select time. Maybe whatever you do, there will be still 3 blocks. So if this is the case, what else can you do if this is not enough? Okay, so here schedule compression kicks in. What is that? So you can eliminate some parts. Let's say, if purchasing the material and renting the trencher is being done with 2 different person, maybe in 2 different days, maybe you want to eliminate one of them so that one person go to Home Depot, Lowe's, and buy the material and rent the trencher at the same time. So you can eliminate some part of the project. Makes sense? Okay. Maybe you can substitute some less time consuming components and activities with something else. Maybe you can parallelize some of the activities, which I will show you. Or you can shorten the activities. How can you shorten them? Remember how we came up with the project duration at the first place. What we did is actually we did the Simpsons rule and we came up with the duration estimations, and then we add them up and then come up with the project duration after we find out the critical path. Okay, but maybe you want to revisit your maybe some of the activities you want to revisit and estimate the durations a little bit more realistic. Okay, so you can try to shorten the longest activities. Maybe you want to do the easiest activities first so you can quickly get rid of them, right? You may want to speed up. You may want to use more resources. So these 2 things are critical, right? You want to have more resources. Maybe you want to add more resources. When we say resources in the project management, don't only think about money. You can think about machinery, a space like an inventory space. You can be employee, money, time, maybe a clean lab that everybody needs to use, or you have a one testing or one software or one top secret computer network that you need to use it needs to be used by different departments and people. So these are all you should think as resources. Increasing the number of work hours per day, just tell everybody, hey, we are We're running out of time in the project. We're gonna be late, so everybody will work, not 8 hours, but 12 hours or 10 hours every day, or come back on Saturday or Sunday for an 8-hour shift. Okay, can you do that? Well, you can, but what are the consequences? Okay, everything has some consequences. So you want to crash the project. Okay, so this is called crashing. What are some of the risks to compression? Okay, what are some of the risks to compression? Think about it for a minute. Well, if you tell people to work, another 4 hour after 5 every day or every Saturday, then there will be, some tests skipped. There will be fatigue. People will be, working hungry, and people will be working like not motivated, and there will be some, you know, injuries, and people forget to do some, important tasks. So quality will go down, motivation will go down. Everybody will be, tense and intense and angry. So be ready for those kind of stuff if you wanna really, really like crash with giving, overtime, quality issues, errors. But people will make more errors, right? More time finding additional resources than time saved. So especially as a project manager, you'll go out and try to find some additional resources which will decrease your time monitoring the project and progress. Then there will be like a vicious cycle. There will be more problems. You will need more money, so you will try to go out and find money. Then you will, again decrease your time monitoring your project and your progress, and guiding your people. Then you will have problems again. New team members are not up to speed. There will be rework and safety issues. There are a lot of questions about job safety and product safety. Others, sure. Please make, under comments, please write if you have any other, if you observe, if you experience any other problems with, doing the compression, either in your project or a project you were working in, made compression and you had some problems. We need to understand the crash versus cost relationship. That's very critical, and think about it for a while. So if you want to shorten an activity, if you want to shorten a project, crash a project, you need money. But what's the relationship? Which activity should I crash? How much money should I need? Where should I start? Should I crash everything? What do I do? Let's see how this can be done. Let's say you have this kind of a network diagram. Right? It's starting, and then you have activity D, activity F, activity G, and then the project is ending. How can you fast track this? Can you fast track? Can you do some activities in parallel? There may be a few solutions to this, but my solution for you is, if you can do it, you can do F and G in parallel at the same time. If you have resources, if you have experts, engineers to do this, if you have technicians, operators, if G can start after D, and if G can be conducted, processed in parallel in conjunction with F, then you can change your PERT with a fast tracking, and now you will save time, correct? For example, for this one, remember this was in your homework and you solved this. How long is this project? Remember that, look at your notes. And then which of the activities may make sense to fast tracking? There may be a lot of activities that can be done in parallel. So think about it, which one of these can be fast tracking? Okay. So let's do an example now. So here's the compression crash versus cost. Let's say your project is starting in 0 and then A, B, C, D, E, F. These are the activity nodes that you are doing, and the numbers are the durations on the arrows. Okay, so where to start? So first of all, let's give an answer to this question. How long is this project? You gotta find out how much is this project. Okay, please do this on your own. These are the days. Okay, 4 days, 6 days, 2 days, 7 days. Does it change the length of the project if an activity G is added between C and E with a duration of 24 hours, which is duration of 1 day? So if I add an activity G in between C and E, what is the duration? What is the overall project completion delay? Okay, what is the schedule slip observed? So I want you to do this on your own, and you can share it in the comment section so you can see others answers as well, and also you can share your philosophy, how you did it, your method, your way of doing it, thinking about it. Okay, so basically what it is saying is you want to add a G between C and E. Okay, so let's go back to the original one. So let's investigate the cost associated with the activities that are to be crashed. So this is your critical path: 4, 6, 7, and 6. As you can see, these arrows are different colors. So this is your critical path. So to analyze which nodes can be, should be crashed first, you want to go back. You want to have such a table that says the activity, what is the time, what is the target crashing time, what is the cost, what is the weekly cost, and you should have such a table. How can you find that? Well, maybe you have this in your project, maybe you know it, maybe you experience it, maybe you ask experts. Okay, you should come up with some kind of this table. I just obscured these numbers because I want you to do it along with me. I made red. These reds are the critical path. A, B, E, and E are critical path. Okay, so which one do you want to attack first? Well, first of all, you want to attack the ones that are on the critical path, correct? You don't want to spend time, and by the way, this is 8,000, I believe. I apologize for this. So this is 8,000. So you don't want to crash the black ones, right? Because they are not on the critical path. They're not on the, so even though you crash them and you conduct them, you complete them in shorter amount of time, the project duration will not change because project duration is decided by the critical path. So first of all, you want to eliminate C and D. You're looking for something on A, B, E, and F. Okay, so here are the target crash times, and this is the cost, like a normal cost, and this is the crash cost. So read it like that. So normally activity 4 is 4 days. I want to crash to 2 days, and the normal cost for activity A is 10,000. If I want to crash it 2 weeks, the new cost will be 14,000. Okay, so this is just activity A. So you want to do the same for B, not C and D, and this is 8,000. I apologize. And here it's E and F. You want to come up with these numbers. Okay, then how do I decide which one to crash? Then I wanna open up one more column for you, which is crash costs per week. Okay, so I am crashing 2 weeks in activity A. It cost me 14 minus 10 is 4,000, divided by 2 is 2,000. I am crashing in activity B. I am crashing 1 week, so I'm shortening it to 1 week, and it cost me from 30,000 to 42,500. then my crash week is crash cost minus normal cost divided by the crash amount, crash weeks, okay, which is 12,000. So now you do this for ENF. So I want to ask you, which one would you go first? Looking at this crash cost time, which one would you go first? And why? Think about the answer. Can you plot it on a crash cost graph? Can you plot it on a crash cost graph? Because it's easier to understand if you put this table on a plot. Okay. So would you like to start with this one, like activity B? Oh yeah, I can hear you saying no because it's 12,500 just to crash it 1 week. Well, if I can crash something with 2,000 for a week, then why not start from there, right? So that's the financial analysis that you want to do. So if you want to put the program cost here and program completion time, okay, and here's the normal operations. So if you want to start with crashing A, okay, you'll crash 2 weeks and you will only spend this much money. And then which one do you want to do second? I can hear what you're saying. You want to continue with F, because with F you can crash 3 weeks and 3,000 per week. Okay, so it brings you all the way to 139. Okay, so which one would you like to go next? You want to go with E and you want to go with B. Well, what happens after B? Well, then, so A, B, E, F. So if you go back, A, B, E, F. So you covered all the critical path activities. So would you like to crash? So if you wanna crash it totally, like let's say you have money and you wanna do everything you can. So the minimum cost to total crash is around $160,000. Okay, what's your save time? You can save, I believe, from 23 weeks all the way to 15, which is 8 weeks. Let's go back and calculate here. 2 plus 1 is 3, plus 2 is 5, plus 3 is 8. Yeah, you can save 8 weeks. As you can see, it came from 23 down to 15. Does it make sense now? So you can easily present this to your program manager and say, no, sir, ma'am, I can save 2 weeks with this much money. And then if we still have money, or if we still need to crash the project, if the customer wants it really early, then I want to go with the crashing F, activity F. And you can easily analyze and show this to your supervisors. Okay, here's the funny things. If you want to do even more crashing, which means if you want to include C and D, then what does that mean? All activities crashed? So if you crash all activities, your program cost will rise up to here. But what's happening with your project completion time, the project duration? Yeah, you got it. It's not really shortening the project. So if I'm not saving any weeks, why am I spending money, right? So I don't want to do this. I want to save time and spend some money, save more time and spend more money until the time and I'm done with the activities that even though I spend money, I cannot shorten anymore. Okay? So that's the crashing cost analysis. So there will be questions in the progress quiz 2 next week on these kind of explanations. So let's do another one. So here I want you to do this one on your own. Okay, so here's the normal time. So here's the time that if I crash, here's the normal cost, this is the crash cost. I want you to find out the weekly cost and decide which one to do first. So find the weekly crash cost for each activities and in which order you would like to start crashing, and think about, as you can see, everything is in red, so we're thinking all the activities are on critical path. I want you to plot crash cost graph, and this will be a homework. I'll post it on Canvas as well, so I want you to submit those things. Plot crash cost graph. If you understood the previous example really good, then you'll be okay to do that. Just one more thing before you go. Why are we doing all these things? I wanna switch to a new topic in this series of lectures. Why are we doing all this? Why are we trying to crash? Why are we trying to look, the durations? Why are we really thinking on critical activities and critical path activities? Well, it's because of risk. Because of risk. So, risk of not estimating the activity durations, good. Risk of not estimating your budget. Risk of not being able to achieve on time. Risk of giving the wrong confidence level. Okay, so all these things are risks, and we cannot really manage and complete any project without thinking of risk. Okay, and when you start crashing, when you shuffle people around, shuffle material, shuffle other resources around, then you will create more risk. But the thing is, you want to understand the risk from an impact, from a probability and impact perspective. What is the probability of risk occurring, and what is the impact? Okay, so we are switching next week. We are switching to definition of risk and the concept of risk in project environment. We are going to learn what is risk, how can we define risk, how can we manage the risk, and what are some of the risk response strategies. And we wanna identify the risk early, prioritize them, and then attack them with some risk response strategies, and then you want to monitor and control the risk. All right, great. So make sure you complete the homework for next week on Canvas, and you make a good review for the topics that is covered after Progress Quiz 1, because this is kind of a very natural, a natural breakpoint for a Progress Quiz, because we're switching from project management and schedule domain to project risk domain, which is really fun. So we'll see our progress levels. Thank you so much. If you have any questions, please reach out to me, and I'll see you next week. Bye bye.